All right, let's dive in. Today we're talking about a piece of technology that completely changed the game for millions of Java developers. I'm talking, of course, about the Spring framework.
So, you gotta ask yourself, right? In a world that's just jam-packed with tools and technologies, how does one single framework become so dominant? How did it become absolutely essential for a whole generation of Java developers? What's the secret sauce?
To really get why Spring was such a big deal, we have to hop in a time machine. We need to go back to what enterprise development looked like before Spring even existed. And trust me, it was a very, very different world.
You see, Java was exploding in popularity. It was becoming the language of choice for building these massive, complex applications for big businesses. Enterprise apps. But here's the catch. With all that power came a ton of complexity. The bigger the app, the bigger the headache for the developers building it.
This right here, this was the core problem. People called it the tangled web. Everything was just so tightly connected to everything else. In developer speak, we call that tight coupling. Just imagine trying to repair one little part of an engine, but you can't because it's literally welded to all the other parts. You can test things one by one, and a tiny change over here could cause a huge mysterious bug way over there. It just made everything slow, painful, and super rigid.
And right into the middle of all this chaos, a new solution shows up. This is where Spring comes into the picture. And it wasn't just another tool. Oh no. It was a direct answer to the frustrations that developers were dealing with, day in and day out.
At its very core, Spring's mission was crystal clear: untangle that web. It was built from the ground up to give developers a much more streamlined, flexible, and just fundamentally simpler way to build these powerful, large-scale applications.
So how does Spring actually pull this off? Honestly, it can feel a little bit like magic when you first see it, but it's not magic at all. It's just a couple of really, really clever design principles. So let's pull back the curtain and look at the two big ideas that make it all work. The first big concept is called Inversion of Control, or IoC. Now normally, your code is the boss. It's in charge of creating its own parts, managing them, telling them what to do. With IoC, that whole idea gets flipped on its head. It's inverted. The Spring framework itself takes over. It manages all your components and their life cycles, so your code doesn't have to. It's a massive shift in how you think about building software.
Okay, so if the framework is the boss, how does your code get the things it needs to actually do its job? Well, that's where the second big idea comes in: Dependency Injection, or DI. This is how Spring actually does inversion of control. Instead of your code having to go out and search for its dependencies, the other components it relies on, the framework just injects them right where they're needed. It's exactly like having plug-and-play parts. Your component just says, hey, I need one of these, and Spring delivers it. Simple as that.
This slide really just lays it all out, side by side. On the left, that's the old way. Your code is the manager, the builder, the whole shebang. It's doing all this extra work. But on the right, with Spring, your code can just focus on its specific job, because the framework acts like the ultimate project manager, delivering exactly what's needed right when it's needed.
So that's the theory. But what does this actually mean in the real world? All this clever design leads to some seriously tangible benefits for developers and for the businesses they work for.
Let's break down the impact here. First, things just get easier. There's way less repetitive boilerplate code to write, which means developers get to focus on what really matters: solving actual business problems. And that leads directly to the second point: it's faster. When your components are independent, testing them becomes a breeze, which speeds up the whole development process. And finally, that brings us to the biggest win: it's modular. You're building applications out of these independent, loosely coupled pieces that are so much easier to manage, to reuse, and to update down the road.
And really, this one sentence says it all. This is the core value of Spring. It took the tangled, complex world of enterprise Java and made it more approachable, way more efficient, and a whole lot more flexible.
So there you have it. We've seen how Spring untangled this incredibly complex web just by flipping the whole idea of control on its head. And you know what? The ideas it introduced, modularity, loose coupling, they are more important today than they have ever been. And it kind of leaves you with the question, doesn't it? What's the next tangled web out there in technology? And what's going to be the next Spring that comes along to simplify it all?